So welcome everybody to this latest video on 162 Maths, and in this video we'll be returning with Surds with a focus on expanding brackets. Now this video will include how to expand single bracket questions and also look at double bracket questions, and then before going over quite a common contextual question where we use this method to answer a Pythagoras question involving surds. Now before we get started, let's just have a quick refresh. Now when multiplying out or expanding brackets, you can only multiply numbers with numbers and surds with surds. And that's a really important thing to remember, because you don't want to get confused by just multiplying literally everything that you see. So as an example, if we look at question 1, so here we've got a surd and we're multiplying that by a number and a surd. So what I'm going to do is, now if I multiply the two surds together, that's going to give me root 15. And then I've got 2. Now the number in front of this surd of root 3 is just a 1. So what I can then do is 1 times 2, which gives me 2. So the answer then is 2 root 15. Now here with question 2, I've got a number being multiplied by another number, so I can work with that. So 3 times 6 is 18. And then I've just got a root 2. There's no root attached to the 6, so it's just going to be 18 root 2. And there's the final answer. For question 3, I've got 2 times 7, so if I multiply the two numbers outside the surds together, that's going to give me 14. And then I've got 3 times 5, which is going to give me root 15. And there is my final answer. Now one thing that you do want to do is just make sure to see if this can be simplified. So always check, if you can spell it, check to see if this simplifies. And then if we look at example 4 where we've got brackets, so this means 2 root 5 multiplied by 2 root 5. So if I deal with the numbers first, I've got 2 times 2, which is 4, and then 5 times 5, which is root 25. And then we just check, can we simplify root 25? Yes, we can, because root 25 is just 5. So then that then becomes 4 times 5, giving me a final answer of 20. Now the one thing that you also need to do is always check to see if a surd can be simplified before performing any calculations or expanding. Now by doing this earlier, it means that you will be working with much smaller numbers and more sort of appropriate for when you're dealing with non-calculated problems. So if we look at this question here, now root 72 seems like a big number, so I think to myself, can I simplify root 72? In which I can. So that then becomes root 36 times root 2, and that becomes 6 times root 2, which then simplifies to be 6 root 2. So root 72 can be written as 6 root 2. If I then look at another one, so let's look at root 8. So here I've got 4 root 8. Well, that can be written as 4 times root 8, and that can be written as 4 times root 4 times root 2, and that then becomes 4 times 2 times root 2, and then these two things here combine to give me 8 root 2. So 4 root 8 can be written as 8 root 2. And for root 16, well, that's just 4. And there you go. Now you don't have to write all of this down in the question. If you can do it in your head, brilliant. You can go straight to the final answer. But I always say, just to make sure, because it can be quite a fiddly thing to do inside your head and make sure it's getting correct, is just write it down. So from this, what we're going to do is just separate these, or write an equivalent for these. So root 72 I can write as 6 root 2. And then if I open up my bracket, now 4 root 8 I've already worked out to be 8 root 2, so I can write that as 8 root 2. And plus root 16, well, I can write that as plus 4. So all I've done is just written down the simplified answer. Now with this, what I can then do is just go on to expand. So 6 times 8 is 48, and root 2 times root 2 is root 4. And then I've got plus 6 times 4, which is 24, and I've just got the root 2, and so we've got this. Now here I can then simplify this further, because root 4 is just 2, so that becomes 48 times 2 plus 24 root 2, and 48 times 2 is 96, And so the final answer is 96 plus 24 root 2. And there is my final answer. Now that is a lot easier than, let's say, treating this as a right from the start. So if I then had to do root 72 and then 4 root 8 plus root 16, let's say this is on a non-calculator paper, then what I'd have to do is multiply these two things together. So I've got 4 and then it's going to be 72 times 8, which I'll be honest, I don't know if that off the top of my head. And then I've got 72 times root 16, which again is going to be very, very fiddly of trying to work this out. I'm going to have to do some long multiplication to work out what each of those are. And you can see though, by simplifying it, it's a lot quicker to do, and definitely will stump you up if you had this question on a non-calculator paper. So let's have a look at some example questions. So first of all, let's have a look at some single bracket questions. So here, now it's always good to use loops. So root 3 times root 2 is root 6. And then I've got root 3 times 1. So that's going to be plus 1 root 3. And then that is going to give me my final answer. If I simplify that, well, I can't simplify root 6, can't simplify root 3. So the answer then is just root 6 plus root 3. Now I can't write that as like root 9 because that's not correct. There's no addition rule in Surds, so that would be my final answer. For the next one, I've got root 5 times multiplied by 2 root 5, so then that then becomes 2 root 25 plus, and then that's going to be a number times a surd. It's just going to just join those two things together, so that's just 3 root 5. Now with this I can simplify root 25 because that is just 5, so that then becomes 2 times 5 plus 3 root 5, and there's nothing I can do with the root 3 root 5, and that's just as it is, and that gives me a final answer of 10 plus 3 root 5, and there is my final answer. And then with question 3, again multiplying 2 root 3 with 4 root 3, so 2 times 4 is 8, and root 3 times root 3 is root 9, plus, and then I've got to multiply this with this, so 2 times 2 is 4, root 3 times root 2 is root 6. Then looking at this, I can simplify root 9, that's 3, so that becomes 8 times 3 plus 4 root 6. I can't simplify the root 6, so that becomes 24 plus 4 root 6, and there is my final answer. Now I can't join the 24 and the 4 because of BIDMAS, because the 4 belongs to the root 6. It's not something that I can simplify with the adding. So let's then move on to double brackets. So with double bracket questions, this is very, very similar to working with sort of quadratics. The only difference is rather than dealing with letters, we've now got surds instead. So, but you want to treat the surd like it is a letter. So looking at question 4, so here we've got root 2 plus 3 multiplied by 1 plus root 2. So here if I just write out the question, root 2 plus 3, 1 plus root 2. Again, using the loops, I've got root 2 times 1 is just 1 root 2. If you want to write the 1, that's fine. I'll just leave it as root 2, that's fine. And then root 2 times root 2 is plus root 4. Then I've got 3 times 1, which is 3, plus, and it's going to be 3 root 2. Then I just want to go and simplify this. So I can't simplify this first term, so that's just root 2. I can simplify 4, which is 2, plus 3 root 2, and then it's all about collecting like terms. So root 2 plus 3 root 2 is 4 root 2, and 2 plus 3 is 5, and there is my final answer. Now if you did write 5 plus 4 root 2, then that is the exact same thing, so that is fine. Then with question 5, so again I've got root 2 plus 3 and then 1 plus root 2. So the order of the second bracket is different, but again doesn't make a difference. Still got to use my loop, still got to expand it. So 1 times root 2 is just 1 root 2 plus root 4 plus 3. I've just realized this is the exact same question as question 5, so we'll miss that one out. And moving on to question 6, we've got a power, so we've got root 2 root 5 plus 3 squared. Now the key thing to remember is that it is a double bracket question still. So even though you can't see the double bracket, it is still, and I would always recommend you write out the double bracket. Then I just got to expand the loop. So 2 times 2 is 4. Root 5 times root 5 is root 25. Plus, and it's going to be 6 root 5. And then plus 6 root 5 plus 9. Now from this I can then simplify this as being 5, so that's 4 times 5. I can collect these two things here, so that becomes 12 root 5 plus 9. So 4 times 5 is 20 plus 9 gives me a final answer of 29 plus 12 root 5. And there we go. Then for question 7, I've got 2 root 5. So question very, very similar. So I've got 2 root 5 plus root 8 multiplied by, and again it's just being squared, so I've got this. Now again, one thing you might want to do is simplify the root 8. So root 8 is root 4 times 2, root 2 should say, and that's 2 root 2. So I can rewrite this as 2 plus root 5 plus 2 root 2. Now because root 8 is not a big number, you don't have to simplify at this stage, but again when I expand the answers and simplify, I'll end up having to simplify anyway. So let's just write this. I don't know where that plus has come from, so let's just get rid of that. And there we go. So then expanding the brackets, we get 4 root 25 plus 4 root 10 plus 4 root 10 plus 4 root 4. Then looking at this, I can simplify this as 4 times 5. I can collect these two things here, so that becomes 8 root 10. And I can simplify this as 4 times 2. Then working this out, well, 4 times 5 is 20. 4 times 2 is 8. So then that becomes 28 plus 8 root 10. And there's my final answer. Then looking at question 8, so let's just create a bit of space. Let's try. Okay. There we go. So looking at question 8, and we've got root 12, which is root 4 times root 3. And what you'll do is when you've done enough surds, you'll start to recognize that root 12 can be written as 2 root 3 straight away. So from this, that's the only surd I can simplify. So question 8 is going to look like 2 root 3 plus root 3, and then we've got 5 plus root 3. Now here what I can do is I can simplify this to become 3 root 3, and then I've got 5 plus root 3. So then it becomes like a single bracket question. So expanding it out, I get 15 root 3 plus 3 root 9. Root 9 is 3, so that becomes 15 root 3 plus 3 times 3. So would give me a final answer of 15 root 3 plus 9, and there we go. Then for question 9, it looks a bit of a mess, but again, looking at this, we can't simplify any of those. They've already been simplified for us, so it's just straightforward, multiply out the brackets. Although we do need to be careful because we have got a negative in there. So 2 root 3 times 3 root 3 is going to be 6 root 9 plus 2 root 3 times 2 multiplied by minus 2 root 5 is going to be minus 4 root 15. Then multiplying these two, I get 3 root 15, and then multiplying these, I'm going to get minus 2 root 25. Then looking at what I can simplify, well, I can simplify this. I don't know why I've gone grey. So this here, so that becomes 6 times 3. I can join these two things together to give me minus root 15, or 1 root 15, and then I can simplify this as 2 times 5. So then here I've got 18 minus root 15 minus 10, give me an answer of 8 minus root 15, and there is my final answer. Now moving on to question 10. So here we see surds and we see a right angle triangle, and we've got to find x, which is the length of the triangle, or the hypotenuse. So you automatically should think that this is going to be a Pythagoras. So first thing with Pythagoras is we label the sides. So let's call that A and B. And what we know is that a squared plus b squared equals c squared. Now hopefully you can see the link towards what we've got to do here. So we've got to work out what x is. So here a squared is going to be root 6 plus 5 squared plus, and it's going to be root 6 plus 2 squared, and that all equals c squared. Now with this, if I just do this in blue, that's going to be root 6 plus 5 root 6 plus 5, and that's going to give me root 36 plus 5 root 6 plus 5 root 6 plus 25. Simplifying this, it then becomes 6 plus 10 root 6, that is a 10, plus 25, giving me 31 plus 10 root 6. Then looking at this, we've got root 6 plus 2 root 6 plus 2, and that then becomes root 36 plus 2 root 6 plus 2 root 6 plus 4. That then becomes 6 plus 4 root 6 plus 4, which then gives me 10 plus 4 root 6. Now what I've then got to do is add these two things together. So what I then get is 41 plus 10 root 6, 14 root 6 equals x squared. So therefore x equals, and it's going to be the square root of that, so the square root of 41 plus 14 root 6, and there is my final answer. So hopefully that's given you a bit of an insight and made you a little bit more confident to the types of questions involving brackets and surds. And it's important that when you've mastered the art of expanding brackets and you check to make sure that they are correct, that you're then able to adapt that knowledge to more sort of geometric topics like Pythagoras, potentially trig, but things like area, volume and things like that could come into play with using of surds.